Thanks for joining the ITAC Industry Technology Advisory Committee meeting. Next slide. Like always, this meeting is being recorded, and if you could please drop your name and organization into the chat, we'd appreciate it. Also, throughout the presentation, feel free to drop any questions in the chat or raise your hand. Next slide. I'm Nate Fernandez, Technical Program Manager at CalStart. We also have Watson Collins, Senior Technical Executive at EPRI. Andra Rogers, Government Program Manager at EPRI. And Lim, Technical Leader, Electric Transportation at EPRI. Yasna Tomic, Vice President at CalStart, and Liz Hellier, Project Manager to Clean Fuels and Infrastructure at CalStart. Next slide. And we see here all the different stakeholder groups that make up this Industry Technology Advisory Committee. We have charging infrastructure organizations like OEMs, fleets, government agencies, utilities, ports, and associations. So thanks again for being here. Next slide. And the agenda for today will cover a brief overview and e-truck updates. Then we'll get into site typologies and discussion. Next will be grid enhancement strategies, which will focus on managed charging, microgrids, and mobile charging. And lastly, we'll wrap things up with next steps. Next slide. So e-truck is a research hub, and the project's main purpose is to develop and deploy high-power charging infrastructure along key freight corridors to accelerate electrification of the heavy-duty vehicle market. And our work and our goals can be broken into the following categories. I won't go into too much detail here. We have a bit of a packed agenda, but first category is equity and workforce development, then market needs and technology assessment, then research and development, and lastly, public corridor charging strategies. Next slide. And just a quick reminder, the goals of this Industry Technology Advisory Committee are to develop and validate high-power charging technology for zero-emission trucks and to inform statewide expansion of high-power charging along key corridors. And next slide. With that, I'll pass it over to Ken for e-truck updates.
Thanks, Nate. Can we move on to the next slide, please? So the Advanced Transportation Research Center, for those that have been on previous ITAC meetings, we've talked about our plans to build a Advanced Transportation Research Center as part of e-truck. Primary location is a lab in Pomona, California, within SCE's Electric Vehicle Technical Center. I apologize. Just want to provide an update that as of July, we've successfully installed and commissioned all the key site test equipment for what we're calling phase 1 of the lab. Phase 1 of the lab is limited to 480 volt service. It's going to have a 360 kilowatt DC emulator, limited 30 kilowatt AC emulator. The purpose of this lab is to primarily advance the development of higher power charging, but also it's a means for the industry to utilize this space to perform behind the fence testing, work on interoperability, reliability of equipment between vehicles, EVSCs, and additional electrical equipment as well. So the lab is, it's up and running. We are taking applications for phase 1. It's open to the industry and available for use. So I encourage anybody that's interested in testing any equipment or needing a place to do any behind the fence testing before deploying equipment out in the field in Southern California to reach out, check out the website, and there's an application process in there as well. In terms of next steps, we're planning a phase 2 of the lab. This is going to have the 40 volt as well as medium voltage capabilities. This is in construction and development right now at SCE's facility as well. If we go to the next slide, you'll see some photos of the work in progress. Right now, as of now, the 480 volt service is installed, but we're waiting for end of year to get the medium voltage capabilities added to this, as well as we're planning to eventually move all of that equipment that you saw in the previous slide into a outdoor rated enclosure to this new site here, just to increase the capabilities of what can be tested at this facility. So any questions on this lab update? If not, I'll pass it on to Liz.
All right, thank you, Ken. So
I have a question about the lab.
Oh, please.
Yeah, so is that gonna be made available to private entities as well if they want to be testing the
Yes.
equipment? Is that kind of the point?
Yes, that's the point. It's to benefit the industry, just to be a place to perform. You know, we're trying to make it flexible. So if you have a use case for bringing equipment and using the test equipment, you know, we encourage you to apply the website, and then we'll review and evaluate it.
And so those results can be kept private. And there's also cases of some publicly funded testing that will be publicly available too. Is that?
Correct. So that the data portion primarily will be kept private, but we will be gathering some high level statistics on, you know, how many applicants came through, you know, what kind of equipment were tested. We're going to try and keep it high level, and we'd work with the applicants to understand, you know, what can be shared and what cannot. So
Perfect. And may I follow up with you afterwards to get more details of the equipment and such too? Or would it be
exactly.
someone else? Okay.
No, that would
thank
be
you.
with me.
Thank you, Ken.
Right, thank you, Joshua, for that question. So onto the heat map updates for the e-truck project. So as many of you may know, in the ITAC, we have launched the first version of the heat map onto the e-truck website. So we'll make sure to add the link here on this meeting. So this first version of the heat map presents modeled truck volumes. So I'm getting a little bit of an echo. So modeled truck volumes and current truck public parking locations in California. So we're able to track truck travel patterns and movements in California. But also we are monitoring medium and heavy duty zero emission infrastructure in California. And so I just want to pause here for a couple of minutes and kind of go through some of the challenges and lessons learned of kind of monitoring all of this information and gathering this data. So I would say the first challenge here was that there was not one source of information in order to track infrastructure in California. So this map is a combination of sources such as the AFDC locator and the information we get from the Energize grant recipients, but also through direct input from infrastructure developers. So for example, through kind of direct communication, but also we have an intake form. Another challenge here was the data validation process and kind of going through filtering out stations that were not publicly accessible or not accessible to heavy duty trucks, but were tagged as such, for example, in some of our sources, and also filtering out transit stations, which are technically medium and heavy duty vehicles, but not relevant to the e-truck project, which is focused on freight. And finally, a challenge here was defining the purpose of the map. Because on the one hand, this map really is a planning tool to inform the statewide development plan, which will be coming out later on this year. And as such, there is many layers and kind of many items of information that needs to be presented on this map. But on the other, we also wanted to create a source of information for fleets to be able to visualize where charging is currently available and planned. And so we are in a process of updating the filters and how the info is presented to cater to fleet needs on the one hand, and then also creating new tabs on the eTruck website. So having different maps based on the needs of the user that will be available on the eTruck website. One of them being kind of an equity component for our community engagement, or a planning component, for example. Joshua, I see your hand up.
Finish. I don't want to be that guy cutting people off.
That's okay. That's okay. That was the main summaries of the challenges and the updates coming up for HEMAP 1.0. So I can pause here.
Thank you. How do you define publicly available?
Very good question. So we have several definitions. So we have a public station, right? Any trucks can charge at this location. We also have shared locations. So this would be, for example, several companies that share a location, but wouldn't necessarily be open currently for a truck to be able to just come up and charge, but could be open in the future, for example, to add new companies to this shared station. And then we also have semi-public, meaning that it would be subscription-based, for example, or there is a registration process to be able to use the station. So yeah, there are several tiers of public accessibility that we are monitoring here.
Thank you. That's helpful, and would love to kind of have those definitions. I assume there's a place to find the legend definition, but I see where the checkbox filters are, so it's good to know. I find a very gray area, this subscription semi-public thing.
Definitely. So there's also a final fleet needs assessment report that will be coming out later on this year as well, where we go into some of the business models that are being used currently in this sector.
And we talked about this gray area. Is there any suggestions on how we can provide more clarity or questions we should ask? And how can we help in this area, I guess, with this gray area? Any suggestions there?
A few. We can talk offline, Watson.
Okay.
We have a lot to cover today. So
Okay. Okay, perfect.
Matt, I see your hand up.
Thank you, guys. And I don't want to belabor this either. I know there is a lot to cover. And to Joshua's point, I think those gray areas, these charging as a service locations, I think that on the one hand, just initially identifying them and the business structure and really making it clear to policymakers that just because it's there doesn't mean it's available. And there's other constraints that go into, your ability as a fleet operator to utilize that location, being credit score, being, minimum charging requirements, hours of operation, so many different things go into it. So really separating out what I call sort of public as opposed to semi-public, as opposed to the true public, which is few and far between, clearly. So just for that purpose, and again, not to belabor the point, and open to further discussions and how to differentiate, but it's critical to have policymakers understand, or whomever's using this tool, that those sites are not necessarily public. They are accessible to those who have pre-established agreements, but they are not pull up and fuel kind of locations. And I think there's some misperceptions out there because of frankly, the good work that a lot of those charging providers have done to show that, hey, there's charging out there, but it's not for everybody, so to speak, to Joshua's point. And just to make sure, and you had alluded to it prior, that these actual public locations, whether or not there is a mixed use for light duty and differentiating mature, it sounds like you guys really did some work in trying to separate out those two. So kudos to that. And another critical issue for policymakers to understand, especially relative to configuration, pull through, etc. Just it's not as cut and dry. So good work, without a doubt. A great start, and looking forward to continued dialogue. So thank you.
Thank you, Matt. Tony, I see your hand up.
Yeah, thanks. Hi, Liz and everybody. I love the heat maps. I know that E-Truck is focused on California, but can you give me a quick update or status or point me to who brought or because I think that CalSTART or someone, I think there's initiative, right? Of other states.
There is, yes. We also have a national infrastructure map, so we can share that in a chat with you, Tony.
Yeah,
we're also
okay. So that's
monitoring-
live, that's up and going. Okay, cool. Yeah, that'd be great. Thank you. Thank you.
And so this map also monitors hydrogen.
Yeah.
On a national.
So it's the infrastructure, but it's also showing like freight, heat, or volumes.
No. So this for each truck we're monitoring, for example, truck travel patterns. For the CalStart's nationwide map, it really is just
Okay.
a source for fleet
Oh yeah.
operators to be
Okay.
able to.
Right. So the yeah. So the patterns that data is only California.
Mhm.
Okay.
Right.
All right. Get it. Thanks.
And I'll post a link, Tony, in the chat. That breed's got a different project than this e-roadmap, and I'll post the link to that chart.
Yeah, thanks. I think that's
got
the one maybe I'm thinking of, and
that's got more of a heat map thing of
Yeah.
now the challenge with that is that that's a single layer with all electrification.
Yeah.
Not light duty, heavy duty, all that stuff. But yeah, I'll post a link to that. And
Yeah, but no,
we're
yeah.
adding some functionality to that so that you can kind of get the things I think you're looking for.
Cool.
That's
Great.
coming.
Thanks.
I think Christy has a comment as well.
Yeah, can you hear me?
Yep.
Okay,
Yes.
great. Yes, so the Energy Commission also has a heat map. And one of the questions I have is, and we, also struggle with, the trying to make sure that only the public infrastructure is shown on our heat map, and then the shared or private is counted in the private charging, basically a bar chart of number of chargers and ports. But my question is, does anyone have any feedback or offline about the business model for if a station only has public charging? Like, is that something that is just doesn't seem to work that well? I guess that's my question. If anyone has any input on that.
Christy, I can give you
Could-
some input on what
could-
EV site. All of our sites are accessible publicly. All it takes is a credit card and a smartphone. Of course, we cater to customers that sign up for package services, but all of the sites do not need any advanced reservation. If any trucker comes in with a credit card and a smartphone, they can definitely get access and they can charge their truck.
Okay, that's great. Thank you. That's great feedback.
Could you repeat the question again?
Yeah, of course. It's basically, you see, we were seeing so many shared or, the gray area about how the charging station, if it's open to the public or not. And my question it was, does the kind of the business model for just public charging, like you don't need a reservation, is that something that's feasible, like economically? Yeah.
All right, gotcha. Now I get it. Thanks. Yeah, and so this has to do with utilization rates and where the market is and a lot of, a lot of strategies there. And we have done some work on this, but it's not exhaustive to this the extent that we've covered every use case. But we have done some work on that in our in one of our reports. And I'll while we're moving forward, I'll look for some of that information.
Okay, that'd be great. Thank you.
Christopher, I see you had it.
Yeah, I just wanted to add my 2 cents to Christy's question. So under the utility commercial rates, in the case of SDG&E, our EVHP rate, there is a comparable cost to say what you would be paying for fuel at a gas station and a comparable margin that you can add on to that cost. So prior to my time at SDG, I actually worked at a truck stop and actually installed DC fast chargers at that truck stop. So I know pretty intimately the inner workings. So as far as the questions, like, is there a business case to be made for public charging without reservations? I would say absolutely yes. The one caveat to that is you can't the amount of time it takes to charge is obviously much longer than what it would take to fuel up a vehicle. So the rate of intake of that income is slower. But if it's like a traditional style truck stop, gas station, that sort of thing, and then if the customer's localized for a longer period of time, then you're going to see more retail sales for chips and stuff like that. So just my 2 cents on that question.
That's great feedback. Thank you so much. Appreciate it.
All right, so for the sake of time, we do have a packed agenda. I'm just gonna quickly breeze through the rest of the updates. So as you can see here on the right-hand side, we are also updating this map to heat map 2.0, which will be published later on this year. And we'll be presenting the projected statewide charging demand for public charging infrastructure between 2030 and 2040. So here we give an example of how this data could be visualized using a hex format. But again, this is just draft sample results, not to be taken at face value. And we will be kind of kicking in the internal review process with the ITAC on this data shortly this year as well. So looking forward to presenting the finalized data by the next ITAC there. All right, if we move on to the next slide, I'll briefly talk about the equity layer that we're also working on in parallel to the first two maps that were presented above. So ITAC really takes on a community-first approach. And so in this sense, we are also working with the CTAC, the Community Advisory Committee, and then the CBO stipends, which are due to start later this year as well, in order to work on providing tools and visual aids to support their community engagement initiatives in California. And so here we can see one of the first steps that we're taking is really monitoring the intersection of where infrastructure is currently being deployed and plans in California, and seeing how those overlap with disadvantaged communities as defined by the SB 535. And as you can see here, there is significant overlap, which could also be due to incentives that are available only to sites that are being deployed within disadvantaged communities as well. This is a subject that we are kind of diving deeper into as well. And so yeah, just giving you a brief overview. This layer will be coming out at the same time as the second version of the heat map, as you can see here, completed by Q4 2024. So by the next ITAC, we will be able to present this. If we move on to the next slides, just a quick update on reports. So as of June 2024, we have 4 new reports that have been published. So these are interim reports that are heavily referenced in the final fleet needs and technology maturity assessments. So we've completed the first draft of this assessment and kind of doing the final edits for the CEC. So again, this report will be published later on this year. But yeah, just wanted to give you a heads up that you can now reference some of these reports that we have, as a group reviewed internally, and they are available on the ITAC website. All right, so on to the next section. We have a section here on site typologies. So we have been working with our partners ICF and SCAG on developing or defining typical site configurations, or what we're calling typologies, to help us identify in a first instance what a site size would be at a location where we've identified charging needs based on the modeling, again, which will be coming out heat map 2.0. So if we move on to the next slide. So in order to define these typical site characteristics or site typologies, the first step was to identify example sites that we can reference as kind of typical sites for a small, medium, or large facility. So, here we can see that for a small facility, we've identified the WAT-EV site at the Port of Long Beach as a typical site at this size. For a medium facility, we've identified the Foreign Mobility site at the Port of Long Beach, and then for a large facility, the Bakersfield site developed by WAT-EV. And so how these examples help us is that once we start modeling charging needs, we will be able to identify locations, for example, where we've identified 3 to 5 megawatts of grid capacity needed at a site location. And so then we need to identify the land space needed to cater to this capacity, but also the number of chargers and the charging power to serve the number of trucks that we've identified that will be going through this one location. So if we take the example of we needing to serve 26 trucks simultaneously, then we can reference, for example, to the Port of Long Beach site from WAT-EV. So in this case, the land space needed at this location would be 65,000 square feet, and looking at 360 kilowatts chargers and dual port configurations there. So this is very helpful for us to kind of identify some of the characteristics at these site locations. Again, a medium facility, we're looking at around 150,000 square feet. And again, this case is interesting. We have a combination of single and dual port chargers at one single site to be able to charge 44 trucks simultaneously. Again, we're looking at the same charger powers in the WAT-EV sites. The Bakersfield site or looking at kind of a typical large facility, is interesting for us just because we are in the early stages of deploying facilities of this magnitude. So actually later on in this ITAC presentation, we have Emil from WAT-EV that will be presenting kind of a case study of the Bakersfield site and some of the challenges that that WAT-EV have encountered in kind of deploying a site of this magnitude. And again, here we have some characteristics that are very interesting. For example, we have some of the chargers are served by PG&E and so are connected to the grid, whereas some of the chargers are powered by on-site solar. WAT-EV have also dedicated 100 acres for the solar power. Just interesting for us in terms of how do we define a large site and the typical land space that will be needed for these large sites. So if we move on to the next slide, I'm just going to pause here. So based on the examples that were presented above, these are the typical site characteristics that we've identified for a small, medium, and large facility in terms of the number of chargers, charger power, and land space needed for a specific grid capacity. So we just wanted to open it up to gain insights from ITAC members on whether you agree with some of the assumptions that we've identified here. We're particularly interested in, for example, these large facilities. How do we define a typical example of a large facility that we can use when modeling charging needs in California? Do we take into account, all of the grid enhancement strategies and the land space needed for these strategies, and define this as the typical land space that will be needed for future projects of this magnitude? Have we identified kind of the average charger power levels as correct here? So we're looking, based on current examples, we're looking at between 240 to 360 kilowatts. But we do need to take into account that we are looking at a future timeline, so between 2030 and 2040. So what do ITAC members, for example, estimate or predict will be the typical charger configurations and power levels by 2030, for example? Just going to pause here if you want to take your time to read the slides and have any comments.
I think your charger power levels are likely much too low for a longer term view.
Mm-hmm.
That's exactly what I was going to say. Yeah, I'm surprised you're not looking at NCS.
That was going to be my same exact comment, besides the fact that if we could all see into the future, we might be doing something different, but definitely need to account for MCS if we're pushing that far out.
Mm-hmm.
Now your per truck power levels may or may not be that far off if you're putting lots of plugs, one fast and several slower for a given power level. But your peak power levels, I expect to need to be at least 1 megawatt to more per MCS plug.
I'll just chime in and say I agree with that too, based on like the Watt EV sites and their model.
Fully agree with that.
Yeah, that we're all on the same page here. Yeah, I think we need, obviously, Watt EV are already future proofing for MCS. So if we're looking into the future, it's definitely something we need to take into account.
I do think too that for the large facilities, 12 megawatts, such as the one Watt EV Bakersfield, I think that it should, you guys should account for, the solar panels and also, battery storage as well.
Thank you, Christy. So this is something we're trying to figure out right now. Would this be the typical site for, a site of this magnitude in terms of grid capacity, or there could be alternative configurations to this. I believe the Bakersfield site was a grid constrained location, so this could vary by site as well. I don't know, Emil, if you have any insights on this.
Sure, on majority of our solar sites, we're going to have a minimum of 7.2 megawatt of grid capacity, and then the solar could go as high as 25 megawatt.
And in terms of, for example, generating 25 megawatts of solar capacity, what would be the land use needed for that? Would it be the same as the 100 acres that have been dedicated at the Bakersfield site?
About 120 acres.
Mm-hmm.
I want to question your assumption of the number of truck trips per day. I haven't done the calcs on medium and large. But if we're talking 10 dual port, call them 360 kilowatt chargers, you're only really getting 180 per truck, which is probably pretty typical. And they're probably going to need, an upwards of 2 hours or more per truck if they're going to try to fully charge their battery at this. So I'd be surprised you can get even 200 truck trips a day on a 10 dual port site. So, and I'm happy to talk again offline and do more of these calculations. And of course, look to others for their calcs.
To add, I was just doing the same calculations. I mean, are we assuming that they're getting 100% utilization here? That your the charger is occupied all hours of the day, year round?
That was the theoretical assumption here, which again is, I think to your guys' point, it's not realistic, but we are looking to get some feedback on that.
Yeah, I'll chime in on it. So, Paul Blackenbeach. So I think you might need to help out the audience, not just grid capacity, but megawatt hours dispensed. And then to everybody's points here, what's going on with what those charge sessions look like. As soon as MCS type power levels become available on a truck and on the ports, you're gonna see some different things here. So I think you should somehow look to figure out the flexibility and the amount of time per trip and start building out some scenarios on those different power levels. And I'm sure, Emil, you've kind of already worked at that a bit, but I think that the audience just needs to get forward thinking related to the amount of grid capacity you might need and or grow your own electrons to suit the amount of energy that will be spent in short bursts and or longer. In Europe, they're doing a little bit more, I would say, to categorize the durations of the types of trips that you'd expect of these vehicles going through on corridors.
Yeah, I can give some feedback on that. Our average session time right now on our dual port chargers is somewhere around 2 to 2.5 hours. As we migrate to MCS, our expectation is that an average session would be about 20 minutes. And in terms of utilization, our baseline is on an average annual utilization of about 15% in terms of total aggregate kilowatt hours of energy dispensed.
Emil, did you say 15 or 50%?
15.
Wow. Okay.
I think every article I've seen about public charging anywhere, 20% is about the highest number I've ever seen in real life.
Right.
For non-Tesla.
I can't say at any public charging article I've seen of any brand.
We need to shape this in a commercial sense, though, not just consumers on holidays and things. This is a business, and it's going to operate a bit different once utilization is aligned with opportunities to charge.
Yeah, I think that's probably low from what you'd want, but I would not be surprised if 50% was a very good, well-utilized goal to aim for. 100% is completely unrealistic, I would expect.
Yeah, I mean, we got to think about how many of the fleets are actually running overnight operations a lot of times.
Well, if you're in the drayage market in LA Long Beach or in Oakland, you are working 2 separate shifts with a small window on the back end. And most marine terminals now, the major marine terminals in LA Long Beach are actually putting on 3rd shifts, which are hoot shifts that go from 3 a.m. to 6 a.m. So effectively, if you add in a double flex gate, you have 24 hours of port accessibility, which could provide an opportunity for a truck to be working around the clock, literally. So it really depends on the business model relative to whether or not folks are going to be working, quote unquote, overnight.
Yeah, I didn't know that. That's good to know, though.
Hey, Paul, this is Watson. Question for you. So these sites in this table are characterized as small, medium, and large. And I guess that perspective is from the number of chargers. But when I look at the grid capacity on these things of a 3, 7.5, and a 12, they kind of fall into from a grid perspective, a large, extra large, maybe double XL kind of thing. And how do we kind of communicate some of these? Like there's a whole bunch of things that may have those same kind of dynamics, which is like small sounds like it's easy, like makes it sound like it's easy. Those are still big projects. So
Yeah, I for years have been trying to get that communication out there that even as soon as you cross over the 2.5 megawatt level, even at that, the game changes, right? And it will change again as you go up that, based on what voltage is available in the area. When you switch over to transmission connected versus distribution grid connected. These are different games that will be played here for what that capacity looks like. And from our vantage point, 20 megawatts is what we're seeing as kind of that bottom of the top level. And it goes way up from there, depending on what's going on. If you also take a look at the recently kind of shared CEC scenario maps relating to hydrogen, if in fact that hydrogen has a distributed generation out on site and you're using clean electrons, wherever they may come from, it just goes crazy up from there. So I do think you have to get more purposeful about defining the use cases and expectations. Back to the business truck flow that I think Matt, he was trying to get at, or on from drayage, but we got to get to the corridors. And by the way, Germany has recalculated this 4 or 5 times, and every time they come up with a different answer. So I think it's, you're building the airplane while boarding.
So mass, like the trains and transit agencies have facilities where they're getting grid capacity, and these kind of ranges. Is there different skill sets that happen and things that the site host and the owners of that infrastructure, is there different skill sets that happen when you're in that kind of range from the customer end?
Oh, completely. Go ask a hyperscaler data center what different level of skills are involved. The other thing is there's specific thresholds depending on the utility you're sourcing power from. For example, SMUD, if you get over 10 megawatts, you're going to need to discuss with the balancing authority when you start bringing these kind of loads on. So it's another set of approval dialogue and skills to formulate what it is you're trying to accomplish.
All right, thank you, Paul. Thank you, Watson. Just for the sake of time, I think we do have to move on to the main discussion point. But we can, if we have time at the end, we can also refer back to this.
Okay. Are we kicking off this next section now, Liz?
Go ahead, Watson.
Oh, perfect. So this kind of what we were starting to talk about leads into this section pretty well. And we have 3 presenters in this section that we're going to go through. Mike Rowan's going to kick it off from EPRI. Then Craig from PG&E and Emil from Watt EV are going to present. So what we're going to start out with is kind of like a overview of the challenges and the solutions to this mismatch of timelines for these projects. Then after Mike, Craig's going to talk about this utility engagement, and then we'll follow up with Emil, talking about a specific use case on how Watt EV approached this challenge. We'll have dedicated time for questions at the end of the section, and we'll have a bit of a panel discussion after these 3 presentations. They're pretty. We asked all the presenters to be pretty short in their comments in these slide decks, just so we can kind of get to the questions and get this rich dialogue. So, but please use the chat as we're going through to ask questions. And so, Mike, feel free to take yourself off mute and kick us off on this next section. Appreciate it, Mike. Thanks.
Okay, can you hear me okay?
Yeah.
Okay.
Sounds good.
Yeah, what I'm going to cover is we published a white paper just a couple of weeks ago, so I'm going to do a very quick overview of the white paper. Won't get into a lot of detail, but we'll put a link to the white paper in the chat so you can look and review it a little bit more time later. Next slide. Okay, it's going to step through. So go ahead and hit again. When I do presentations, I like to transition, so I apologize for that in advance. So really, the motivation report is this timeline mismatch between the EV fleet deliveries and utility service interconnection. That is, as people on this call are aware, is impacting customer adoption. Feedback from fleets and OEMs that this issue is leading to cancellations and postponements of delivery. So the report trying to understand the causes of this mismatch, which include the project scale and the transformational load additions and how that impacts this mismatch. There's a couple more sub bullets there. Okay, so how do we address this mismatch? Go ahead, we're good. So the first solution, whoa, too fast. Okay. So the solution 1 would be reducing utility connection timelines. If that's the ideal scenario, how do we get utility timelines shorter? Solution 2, then, if you can't, if there remains a mismatch, there's the need to develop and deploy interim solutions, and those solutions can be on the customer side of the meter, behind the meter, or utility side solutions. So those are the 2 aspects that are talked about in this report. the interim solutions and how to reduce the timeline issue. All right, next slide. All right, so interim solutions. There's the customer side. You got what's the most common scenario right now. How do you utilize existing facility spare capacity using temporary chargers? How do you just make do? One of the underlying premises of the report and in these discussions is often just a few hundred kW is enough to get started. In many cases, instead of waiting for the multi-megawatts that may be needed, fleets are saying, if we could just have a few hundred kW, we could get a few trucks started, we can use some temporary chargers, that at least gets us off the ground. So how do we do things that will allow, even a few hundred kW to get started initially? And on the customer side, that comes from the facility, where can I find some spare capacity, put in some interim chargers, even if it's not the ideal location, but allows to get started. Also, you have distributed resources as well on temporary basis. There are customers today using diesel generators and natural gas generators. Obviously, the optics of that is not very good, but actually in many cases, the emissions are actually better, even if you're using a generator, just because of the difference in the emissions of a stationary generator versus a onboard engine. But distributed resources on the customer side. Then on the utility side, you have similar options. You can use the utility side DER, which has some advantages. But one of the things we talk about in the report is the utilization of a temporary construction service for partial capacity. If you think about it, the common paradigm on building structures in the utility, if somebody's building a 2 megawatt building, everyone expects and assumes that temporary power is going to be needed. I need a few hundred kW for construction until my permanent service get delivered. So how can we use that paradigm in large EV charging projects? 480 volt, 400 amp service in many cases, that gets you a few hundred kW. And in many cases, that's enough to help a customer get started. So how do we change this paradigm then and really treat in some cases like a building construction, that everybody expects that some temporary power and construction service may be needed. And in many cases, that is a solution that can help from on an interim basis as we move forward. Okay. All right, let's step through this a little bit at a time. So if you think about the connection timeline, this is how do we reduce the connection timeline? So in this spectrum, you've got green is good, red is bad. So if you think about it, if in general standpoint from a customer load request, if a customer requests a lot of load, it's going to push things toward the red side of the timeline spectrum. If the customer asks for a lower amount of load, that's going to generally help you on the green side. Conversely, on the utility side, hit it once, whoever's controlling it. So utility available capacity rating, if there's a lot of capacity on the utility, that's going to tend to push things to the better on the timeline. If the utility capacity is low, it's going to push you to the red side of the timeline. But what we're seeing in the world today is we actually have some kind of the conservative nature of the industry can work against us. Said that engineers are conservative people. Utility engineers are conservative engineers, and planning engineers are conservative utility engineers. So as a result, we end up with some of this uncertainty. Customer load requests, maybe high capacity ratings tend to be extremely conservative. In most cases, taking the worst case scenario, the maximum possible load that a customer could request, assuming it is coincident with the peak on the circuit, and that drives a longer timelines. It drives the planning requirements much greater. So how do we address that? There are different things as we can move across the spectrum. Go ahead and hit a few times again, whoever's controlling. On the customer side, some of the estimates start with the maximum charger capacity and assume all trucks are coincident. With experience, operational load diversity. All right, can we use a charge management system to optimize to a rate tariff? Again, a couple times, hit it again. Can we use CMS to optimize to a demand limit? Can we use charge management to integrate with utility signal? To the extent we can do these things, we're moving we're generally pushing things toward the green side of the spectrum, and we're increasing the likelihood that the timeline mismatch may not be as severe. On the utility side of the equation, you have the same thing going on. Go ahead and hit it a few times. So utilities take the maximum possible load and assume it is coincident with the annual circuit peak. When you do that, you're going to push things to the far left on this. And that is still the most common way of doing capacity in the utility industry. Not everyone is doing that, but that's still the majority. Then if you're taking a diversified load, that can move you a little bit better. If you take the customer load profile and apply it, to the time of day of the annual peak, you start getting in better situations. Do utilities accept the charge management to limit KW demand? Do they trust the customer CMS system? Can they apply seasonal, monthly, or time of day dynamic capacity limits? And on the far right, one more time, near real-time capacity signals. So what you see on the top part of this, what moves a customer load request from red toward green? Really, that comes with experience. It comes with programs, but it really just comes with experience and knowledge. On the utility side, what is driving utilities from the red to green practices is really the scale of projects happening, both in size and in number. So because of that, you see most utilities are still operating on the red side of the spectrum, maximum possible load coincident with the annual peak circuit. In California, with PG&E and SCE, they're starting to push to the right-hand side with the LCMS program with SCE, the Flex Connect program that PG&E is doing. In essence, the utilities there in the areas with a lot of scale are realizing business as usual. The past planning practices of the left-hand side of the spectrum will not cut it. We've got to do some things that are more innovative. So we see the California utilities pushing over there with different programs that recognize the load shape of the customer and adjusting planning practices differently. Okay, next slide. So in the white paper, we have a list of some of the best practices that have been seen out there. We won't take time now to go through all of these, but just to show these are listed in the white paper. Also some recommendations. Hit it one more time. Some recommendations that are listed. Again, we're not going to go through these right now, but you can scan them real quick. But the white paper goes in a little bit more detail on some of these. So the final slide just gives, we'll put a link to this white paper in the chat. But again, this was looking at how do we account for the mismatch in timeline between vehicle deliveries and utility capacity. And so it takes a look at it both from an interim solution standpoint and maybe ways of improving that connection timeline.
All right. Thanks for having me today. My name is Craig Castro. I'm an EV fleet onboarding specialist with PG&E. I just want to quickly discuss some insights that we've gained from customers who've participated in PG&E's EV fleet program. And just for some context, the EV fleet program assists PG&E electric customers who are planning to electrify their medium duty, heavy duty, or off-road vehicle fleets. Participants, they receive installation of infrastructure up to their new customer meter at no cost. We provide incentives and rebates to offset their out-of-pocket costs for construction and chargers. And then we also provide comprehensive support throughout the completion of their EV charging project. So when it comes to early engagement and planning, dialogue is very crucial between the customer and the utility. And we need to have that right from the start. It's important for customers to have made their final decisions around their 5-year plan, both for their vehicle and their charger commitments, so PG&E can properly design and build out the scope of their project. Changes during the preliminary design phase can result in delays and redesigns, which can negatively impact the timelines to complete a project. We also advise if the customer has a legal team, have them review the terms and conditions of the EV fleet program contract early, just to avoid a delay later when a contract is issued to the customer. Customers should also try to line up their electrical design contractor team early and have them involved throughout the process during phone screens, site walks, Material design changes after a contract is signed can result in penalties and delays. So a customer should make sure that their final decisions are made prior to signing a contract for EV fleet. With regard to power and capacity management, an EV fleet application is going to help the PG&E identify and build around the power needs requested by the customer. A customer can also review PG&E's ICA maps, and those are publicly available for any PG&E customer to identify whether a site may or may not have power constraints. It is worth noting sometimes the ICA map will show 0 load hosting capacity available, but the customer may still have charging ability during non-peak hours. An application for EV fleet will allow PG&E's capacity planning team to look at the specific substation feeder information to see whether power constraints exist at that specific site of the project. The good news is only about 15% of EV fleet projects face capacity constraints, and PG&E's developed some strategies that can help unlock additional capacity until permanent upgrades are completed. As Mike mentioned, Flex Connect is one of those strategies that we've started piloting. This information will be confirmed during the capacity review check as part of the EV fleet site evaluation process. So that's when we'll really know what the capacity looks like at that point. With regards to managed charging and storage integration, customers may install battery storage or solar along with their new EV charging service, but you won't be able to connect the solar array or the battery storage until a new meter panel and a meter is set at that site. So you can install the infrastructure concurrently with an EV charging project, but there's specific items such as a meter number that's going to be needed for our electrical grid interconnection team to actually get that service online. Any site that has smart charging capability can take advantage of solar power and or battery storage at that new service. But it's worth noting that projects that have proprietary or non-smart charging can't install solar or battery storage until after 5 years of site activation due to CPUC data reporting requirements. For site planning considerations, regardless of the project size, early dialogue again with the utility is crucial towards the implementation of a successful EV charging project. Customers knowing their 5-year plan, both for their vehicle deployment and their EV charging needs, it's very important to ensure project and site designs are accurate early in the process. Again, any changes to that process can affect timetables. If you're a large load site, you may want to review the ICA maps prior to participating in EV fleet. And some customers may need to pay for a large load study to verify and reserve their future large EV project if there's not sufficient data on the ICA maps. Customers can use the ICA maps to identify locations which may have access to considerable capacity and aid with potential site selection for customers looking to build out their EV charging sites. There are going to be some updates to ICA maps in the future, which will give customers more robust data to aid in the site identification process. When it comes to the EV chargers themselves, we always recommend choosing a product that's on the PG&E and SoCal Edison approved product list. And that's extremely important because those products have been vetted to meet certain utility, safety, and communication standards. It's also tied to potential rebates where the customers can get up to 50% of their EV charging hardware costs covered if they're transit agencies, schools, or customers that are located in a disadvantaged community. Choosing products that aren't on that approved product list could result in forfeiture of potential rebates, along with potential project delays because those products will need to be evaluated and vetted by PG&E's engineers just to make sure that they're safe to use on the PG&E grid. And that's all I have. I'd like to toss it over to Emil.
Yeah. Hey, Craig, thanks. Appreciate that.
Yeah.
You'll notice there's a couple questions for you in chat there. So
yeah, I'll go ahead and post that link.
Okay, perfect. Yep. Great. Over to you, Emil. Go ahead and take yourself off mute and
thank you, Watson. If you could go, please, to the next slide. Thank you. So I'll be happy to talk about a little bit on the challenges that we've had in executing on our project in Bakersfield. As you've heard, this is among the large sites that has been identified. This slide, initially, I would just want to talk about what a finished site looks like. This is roughly 120 acres including the solar field in the background that you see along with the paved area, which is around 12 acres. You may want to ask, why did we choose this particular site in Bakersfield and what the significance of the location was? I'll talk about some of the decision criteria leading to that site, but one of the most important factors was to be close to the major distribution centers. So this site was chosen because of very close proximity to Highway 99, which handles a lot of the freight traffic into the Central Valley. And it's very close to major distribution centers in both Bakersfield and Shafter, which is about 5 miles away from this site. And that hosts distribution centers by Amazon, Walmart, Ross, Target, and a few other major retailers. What you see in this slide, which was taken on mid-May at the time of our opening of the site, is the mix of our grid-connected chargers on the right-hand side and the MCS and CCS chargers, which are solar-powered on the left-hand side. And you see the building facility that we put in the center with the driveway coming in for both northbound and southbound trucks. We actually had to make some level of off-site improvements on the highway to allow for the access to the site. So the range of the activities and challenges that we had on this in a greenfield site development was fairly extensive. So I'll talk about some of those challenges as I go through the next slides. Next one, please. Just to give you a highlight about the capabilities at the site, we have 16 dual port 360 kilowatt chargers, which are connected to the grid. They're powered by PG&E. We have an additional 15 single port 240 kilowatt chargers, along with 3 MCS at 1.2 megawatts. The power between those 240 kilowatt chargers and the MCS chargers are shared. So we have power conversion modules that convert 480 kilovolt three-phase AC into DC, and then that power is shared between CCS and MCS. I'll talk about it a little later, but that was part of our decision to make sure that we have a path forward in terms of future-proofing our development and have a migration path from CCS to MCS. What you see in the center is the solar field deployment. Initially, the first phase of the project was sized for 5.2 megawatt DC, approximately 3.6 megawatt AC capacity. We used a unique configuration for the deployment of our solar, which was the first time using California, which in itself presented some interesting challenges. Finally, in terms of the deployment with the grid connection, we wanted to make sure we have some level of resiliency. So we have both access to the grid on the 16 dual port chargers and the solar, which is used during daylight hours for the charging capabilities. Next slide, please. So a lot of the lessons that we've learned from this particular project is being applied to our roadmap for expansion of our network. What you see in this slide is our active development plan. About 5 sites are currently in operation in Southern California, including Bakersfield. We have 4 additional sites similar to Bakersfield planned along the highways, 3 of them on I-5. The locations that are identified on the map as Taft Highway, Gustine, and Sacramento. Those are all very large solar sites. And then we have another one in Blythe, which is very similar. All of these are on 100-acre plus properties, which are going to be very, very similar to Bakersfield. We have about 5 sites in total, which are in PG&E territory, all going in through planning stages right now and reviews with PG&E, and some of the other sites in Southern California and Southern California Edison territory. We have 1 site in Sacramento, which is in SMUD. Generally, a lot of the lessons learned from Bakersfield has been applied to the development of all of our sites, which you'll hear about in some of the challenges that I'll cover. Next slide, please. So the very first challenge that we ran into was a massive amount of grading. I mean, it's one thing to really talk about a 120-acre plus site. It's another thing to get it ready for the kind of installation that we have here. And what you see in this picture is a kind of a depressed land with a picture taken from top of a hill by Highway 65 that had to be graded entirely to create the facilities that we had. The depressed area of the property originally was actually a gravel pit that was used by the adjacent production facilities for concrete production. So it created sort of a convenient area for us to have this solar in a depressed area of the property. Next slide, please. This is where you see massive amount of machinery at work. We had a huge amount of dirt that had to be moved from the hilltop close to Highway 65 and create the area both for the solar field and for the paved area for the truck charging and for the trailer parking. This was a huge challenge, quite expensive in execution that went beyond what we had originally budgeted. But aside from that, some of the challenges we ran into was there wasn't really any water available at the site. We had to create facilities also for the sewage with septic tanks. So those are additional challenges that you would run into in execution of large sites similar to this. Next slide, please. This slide shows the final paving. You can see the layout of some of the areas where we've separated for the deployment of the chargers and the boundaries of the property for the paved area. And on the right-hand side was the portion that we graded for the solar field. And you can see the layout of the portion that eventually got paved for the deployment of all the chargers. And you can see on the portion of Highway 65, at the time we took this picture, Highway 65 had not been expanded, so we had to create a speeding lane coming out of the site going north, and then also a breakout lane coming on northbound to be able to have a turn lane, both right turn and left turn lane. So those were additional elements that you have to include for a project of this size when you're going through the planning stage to make sure that off-site improvements are included. Next slide, please. The other major challenge or interesting issue that we ran into, one of the reasons that we selected this particular site and we got enamored with it was a transmission line actually passes through the property. And you can see that portion of the transmission line at two locations on the poles on the property. One of them, after we've done the paving, you can see it's on a sort of the hilltop that remains there in the property. But the initial thought process here was that we should be able to get the ability to put in a private substation and have access to the transmission line. Unfortunately, that didn't work out. We are doing actually that in our project in Sacramento. We're allowed to put in a private substation to connect to SMART 69 kV line. But in this particular situation, after discussion with PG&E, we determined that that was not a viable option. So we ended up having to switch gears and apply for access to the distribution line. But just a point of comment, do not necessarily get enamored with the transmission line passing through the property before checking whether a private substation is possible or not. Another slide, please, if you could switch to the next one. So this is a picture of the solar field after the current phase has been deployed. The initial thought process was that we would actually have the solar field operated in a grid following form with Rule 21 interconnection. The challenges we had run into was the time that it would have taken for us to complete the interconnection process was not fitting into our entire timeline. So that resulted in us switching plan and implementing the solar as a islanded operation. But at the point where we made the decision to have the interconnection completed, we decided that the AC coupling had to be done at medium voltage. So that resulted in changing our application to PG&E from having secondary voltage interface into medium voltage. And that ended up really as the base voltage that we chose for the execution of the project as we went forward, both for the grid operated portion as well as for the solar portion. Next slide, please. So having selected the medium voltage as the base facility to interconnect to PG&E, that presented another new challenge when we ran into having to put in a medium voltage switchgear, which had to have the both incoming section facility, metering section at medium voltage with CTs, and then having vacuum breakers for the medium voltage. We ran into huge challenges in terms of supply chain and being able to get a medium voltage switchgear of that nature on a timely basis. And the end result was that we received some guidance from PG&E, helping us to have an alternate solution with overhead connection, which reduced both the cost as well as the time to get connection in medium voltage. Next slide, please. So this shows a picture of the recloser that with PG&E's guidance, we were able to secure. It allowed us to achieve medium voltage interface. The meter is installed directly on the pole and allowed us to have the behind the meter medium voltage lines carried out through the property to be able to extend them all the way to the chargers. I mean, as a result of this experience, actually, we've migrated to all of our new sites asking for medium voltage interface into the utility. And wherever overhead lines are accessible and allowed by AHJ, we would prefer to have actually an overhead interface because it reduces, again, the cost and the time in execution without having to avoid a ground-mounted switchgear. Next slide, please. So this slide shows the final deployment of our 16 dual-port chargers connected to the utility facilities. We had to deploy 2 separate ground-mounted transformers, and what you see on the right and left-hand side of the picture is a integrated power module with a medium voltage disconnect capability at the front end, and a dry transformer and a secondary voltage distribution that fits in to 8 chargers each on the right and the left-hand side. Next slide, please. So this presented another challenge where we ordered and purchased this integrated power module. And when we ended up having to actually power this up, the AHJ had not seen anything like this before. So we had to go through quite a bit of process in terms of on-site review and verifications and on-site labeling to make sure that we could get this piece of equipment finally approved and green tagged before we could power it on with the connection to the utility. Next slide, please. So this is a picture of our solar deployment. Originally, we planned to have single-axis tracking, but because of both cost and time to execute, we decided that we should look at an alternative that allows us fast deployment. So we selected a solution that comes in a containerized form, all pre-wired, and it's more like an accordion that you can stretch out on a flat ground. I mean, the level of accuracy that you need to have in the grading is fairly tight. But the immediate challenge we ran into was, since nothing like this was ever deployed in California, we had to go through quite a bit of seismic and wind load analysis that make sure that we could get the permits and approval for deployment. Just another point that doing a design on paper compared to actually execution and getting it through permit process is quite challenging, and you run into a lot of unknown issues in the process, but has been a great learning experience for us applying into the other solutions. And as a result of this deployment, actually, we have refined our solar deployment into the other sites using a mix of both this kind of deployment and single axis tracking, where floodplain levels may be an issue in the deployment of this type of solution. Next slide, please. So this is a picture of the solar connected chargers. You can see a mix of 15 single core 250 kilowatt chargers, along with the 3 MCS chargers on the left-hand side. Those provide for a pass-through of a truck and a trailer. The power between the 1.2 megawatt and 5 of the CCS are shared. So you see 3 of the 1.2 megawatt power conversion cabinets next to the containerized substation, which we had to also get involved in design and execution. So that center cabinet is a medium voltage substation with 12 kV line coming in from the solar field, and then it goes into a transformer and a secondary distribution that goes into the power conversion cabinets. But this was a solution that we had to completely design in-house and execute to make sure that we have a path forward from migration from CCS to MCS. Next slide, please. And finally, this is the deployment of our MCS charger with our CEO holding out the charger, waiting for a truck with that capability to come in. Now we're a little bit advanced of the industry in terms of deployment. We wanted to make sure that the chargers are there, and we remove the excuse from the OEMs that the chargers are not there for the truck. So right now, we're actively working with the OEMs to make sure that we have access to the chargers as we progress. Next slide, please. And that about wraps up on my presentation. This slide is just the charging capabilities that we developed under our own subsidiary called Charge America that went through EPRI certification before the deployment. Thank you very much.
Yeah, thanks, Emil. Yeah, so these were great presentations. Oh my gosh. Please type in chat questions or raise your hand. I do have some questions for the group here if you want to move on to the next slide there, but I'll try and make sure I'm following the chat and seeing if people have questions for any of the presenters. But just for the general audience, we had the thoughts on these various approaches. So Mike talked about some of the interim approaches of like how do you accommodate some of these projects, charging infrastructure projects, and how can you kind of scale into this stuff? That's what Mike talked about. And then Emil, came home with how's a large site, deal with the challenges of the large site, and if you notice, I asked the question, there's different skill sets required for these larger sites. This isn't like putting in, getting your local electrician to put in a couple level 2 chargers in an office building. There's a different kind of set of skills that are required to execute on these larger projects. But anything that, like any ideas on how to address these challenges that we didn't talk about that people are seeing out there? But I'll, unless there's no questions, I'll move on to some kind of things here. So one of the questions I had, which is in the middle of this slide that's up here, is when we're doing our planning for, you know, the statewide plan, what you heard Amel talk about is, you know, like, how do you pursue this when there's large sites? You know, and you do a lot of chargers at these large sites. And that's one kind of strategy, and we can kind of like integrate that into our planning approach. The other way is you know, there's smaller, less costly projects on the utility interconnection side that you could do, but you'd have to do a lot more of smaller sites, and so we're trying to think through what this was a great setup for the things that we're trying to think through in the E-Truck project is how do we accommodate, or how do we think through this in the plan that we're presenting and developing now? So we have the data on like what's the charging needs, but we don't, you know, we're not the ones that are going to be deploying the solutions, and so we're trying to look for feedback on the solution space of is the solutions look like, you know, a lot of projects like what Emil has, or is it something that on the other end of the spectrum, which is like, you know, two chargers at a, you know, MCS chargers, or a handful of CCS chargers at a site that don't require this level of effort, or is it a combination of the two? And how do we kind of think through that? So that's kind of one of the things we're looking for, some guidance in how do we approach that, because there's different ways to provide guidance on the plan. So but Emil, any comments on the question I was just asking there? Maybe I'll start with you.
Absolutely, absolutely. Really the biggest issue that we've been confronted with is this transition from CCS to MCS. We were forced to have the kind of deployment in Bakersfield with that mix because there was uncertainty about at what point in time would you have MCS trucks. The conclusion that we've come to is that the adoption in the industry isn't really going to happen unless and until you have MCS trucks. If you really look at our current deployments for the fleet of CCS capable trucks that we're deploying right now, you would have to spend 3 hours on the average on charging. If you consider the time for the driver to go there, charge up and come back, CCS can work for behind the fence charging, but for on-the-road charging, it's just not viable. So as you migrate to MCS, and if you accept that at some point in time, the OEMs will step up and you have MCS trucks, the kind of deployment that would make sense is to put in somewhere in the order of 4 to 8 pass-through chargers, and you would really be following the same workflow and the processes that the truckers, transporters, and the truck stop operators follow today. And we've had a lot of discussions with actually truck stop operators to get feedback. And their view is that really stationary charging is just not viable. So in terms of our future deployment, once we have enough certainty about availability of trucks, and right now our forecast is that you would have at least from 2 or 3 manufacturers by 2026 MCS capable trucks becoming available. We're kind of migrating more to changing our design philosophy and deploy somewhere between 4 to 8 CCS chargers, which would reduce the complexity of deployment completely, but you need to have sufficient energy for that.
Great. Mike or Craig, any reactions or comments on the question there?
Well, I think from our standpoint, I work with a lot of customers who are looking to put in charging behind the fence. So it's not necessarily public facing charging, which in and of itself is kind of a different snowflake altogether. Typically what we've seen in conversations with customers is they think they need like more powerful charging than they actually need when they break down their operations and figure out how many hours they actually have to charge these vehicles overnight. But I do agree with public facing charging and corridor, like the California corridor, whether it's 5 or 99, there's a lot of hesitancy for a lot of these Class 8 operations to adopt battery electric vehicles, just because right now the technology just doesn't work for them. What we've seen is a lot of success in the smaller type vehicles, like your Class 6s and lower. In our program, you can have a vehicle as small as an electric pickup participate in the program. So it's really a different kind of beast altogether. But I do agree there's going to need to be some additional planning on the public side to be able to build out these sites and build confidence for a lot of these companies that are doing that long haul trucking to be able to adopt the technology.
Oh, great. Hey, Mike, I was just going to take a couple audience questions. I'm sorry for.
Okay.
Yeah, thanks. So Christy, yeah, because we only have a couple minutes left. Christy, you were, I think, the first one to raise your hand.
Yeah, thanks. So just a question about the question on the slide about what site deployment approach should eTruck prioritize. I'm a little confused because given the current, range constraints of the trucks, I mean, it seems like you would need both centralized and
Okay.
dispersed. So I just wanted to point that out, and also for public charging build out along corridors, the CEC has a recurring corridor solicitation that we may be bringing to forth soon, but round 1 was a success, and round 2 hopefully will be coming very soon. I just wanted to note that.
Thank you. Yeah, Peter, I think you're.
Yeah, thank you. I'm with SMUD, by the way. And so speaking, I think from a utility perspective, I think to me, the better way to frame this question is actually related to the prior slide that was shown around the 3 different sizes of sites and the necessary capacity for each of those sites. Because if it is framed that way, then you have a site design or some blueprint, which then could be configured as centralized or dispersed, however you like to do it, but that I think better maps to distribution system infrastructure and understanding what then the local impacts would be, knowing what the power requirements of whatever blueprint site deployment approach eTruck is using. So I think there's, in terms of application to utilities and planning what sites might be coming down the pipeline, they can have a better sense of where things map.
So maybe saying this question a different way, if where there was the going back to your framing, Peter, where there's small, medium, and large projects, we know with the large projects, you're going to have to do what Emil did largely to, and is that a reasonable assumption to believe that the industry is going to be able to build out, a large scale deployment of that. It's awesome what Watt EV is doing, but if we're electrified all the trucks, if we're planning to electrify a lot of trucks, that we're going to need a lot of those kind of sites, and so is that what we should be outlining of what the future looks like? When you do these scenario planning, like the scenarios, which is there's that case in the future, or is there a different future where we try and suggest that there's easier projects to implement? So that's what we're trying to figure out, that are smaller.
Yeah, and I don't think I'm necessarily trying to suggest that the Watt EV is the only approach, but I guess just having the options to this question be very binary and centralized or dispersed.
Okay,
I actually think there's more nuance to each of those, and that nuance is important as it relates to siting as it relates to a utility's ability to serve, and as it relates to any behind the meter solutions or utility side solutions like what Craig discussed around Flex Connect and SCE's program that should be included in a study so we know, so it's a bit more comprehensive in what it is looking at, because I do think we kind of need all those options, right? In our tool belt to be able to make this possible. However, it ultimately looks as centralized or dispersed, but it needs to include the analysis of all those solutions.
Perfect. I know we went a minute over there. Nate, do you want to just drive us home? That I really appreciate the comments, discussion, and the presentations from Mike, Craig, and Emil. Thank you everyone for participating. Your active engagement, comments, and questions. Go ahead, Nate, and wrap this up, please.
Thanks, Watson. So next steps are, if you have any feedback on the Advanced Transportation Research Center, you can shoot those over to Ken at kenlim@epri.com. Any general additional feedback you can send over to me at nfernandez@calstart.org. And as always, we'll be sending out our meeting summary email and recording soon. And if you have anything that you'd like to present, any ideas for a future panel discussion suggestions, please email those to Liz at ehellier@calstart.org. And thank you all very much again. We can have the next slide of thanks again, all our partners and all of our committee members. Hope you all have a good rest of your week.
Thank you, everybody.
Thank you.
Thanks.
Thanks, everyone.